Okay, this one we can just go ahead and, so before we do all of that, make sure that it's off. So we power off, and then we're gonna put, is it this one, eh? So let's just put that one on the slot. I don't know which slot is it. Okay, and then we're gonna power on, and then let's go. Okay, so it's still booting. Then we can just wait for it. Okay, and let's go and give it a name. So this one is gonna be RTR PTA 01. Alright, and then we need to connect it to Johannesburg using the new serial link. And then we're gonna power it off. Power it off. And then we're gonna add another serial somewhere here. And then don't forget to power it on. Okay, so let's go and add a serial. So that's serial 00 from Pretoria, and to serial 00 in Johannesburg. Alright, so let's go to Bloemfontein. Oh no, Bloemfontein, you see I added the wrong router. I need 29. So let's remove this one. So we're gonna go back to 29. Okay, so we also needed to power it off, and then we're gonna add this and then power it on. A name, so this one is gonna be RTR BFN. BLM, RTR BLM 01. And then, but this one I'm going to connect it to Cape Town using a serial link. So let's connect this one to Cape Town. So I'm going to put it on serial so we added RTR PTA 01, so which is a 2901 router for Pretoria, and then we connected it to Johannesburg using a new serial link. So if it's needed, like we did, you can add that HWIC2T if needed. And then the WAN link between Johannesburg and Pretoria uses a subnet of 10.10.102.0/30. And then the Johannesburg site is going to be 10.10.102.1. And then the Pretoria site is going to be 10.10.102. All right, and then we need to add a switch in Pretoria, and then a PC in Pretoria. So let's add a switch. And let's somewhat give it a name. So it's gonna be SW PTA 01. And then we need a PC. So let's so the PC is gonna be PC PTA PC1, and then let's just give it give it an IP address. Now that's gonna be we said Pretoria is gonna be .6, ne? So it's gonna be 10.10.6.10. So it's a /24, and then the subnet since it's a /24, it's gonna be 255.255.255.0, and then the gateway is gonna be 10.10.6.1. Complaining about the gateway because we haven't set it up, but that's fine. So let's do the connections. So with a straight through, so it's a PC to fast Ethernet 0, and then again with a straight through, a switch gigabit Ethernet 0 to gigabit 00. All right. And then so we also did the same thing. We need to add a switch in Bloemfontein. And then let's just give it a name. So this is gonna be SW BLM 01. And then we need a PC in Bloemfontein. So it is gonna be BLM PC1, and then the IP is gonna be 10.10.7.10/24 network. So that means is gonna be 255.255.255.0, and then the gateway so that's 10.10.7.10. I don't know why it keeps on saying invalid. That's 0. Okay, then the gateway will be 10.10.7.10. 10.7.1. Alright. Now on the Bloemfontein, it's connected to Cape Town using a serial link. Now a WAN subnet is 10.10.103.0/30, and then the Cape Town site is 10.10.103.1. Bloemfontein site is 10.10.103.2. Okay, so let's go to Pretoria and then configure the interfaces. Okay, so we're gonna enable configure terminal. Host name, LTR PTA 01, and then interface gigabit Ethernet, which is 0/0, and let's give it an IP address of 10.10.6.1, and then the subnet is a /24 subnet, /24 network. And then no shutdown. Exit. Now let's do the interface serial 0/0/0, and then the IP address is 10.10.102.3.2. Remember, Johannesburg is 10.10.101.1. Actually 102.1. So you should not actually get confused there. And then we're gonna do a /30 255.255.255.252, and then no shut down. And then exit, and then end. Okay, now let's go to Bloemfontein and then enable and then configure terminal, and then hostname RTR BLM 01, and then interface gigabit Ethernet 0/0, and then IP address it's 10.10.7.1, and then it's also a /24 network, and then let's do the interface serial 0/0/0, and then the IP address. Cape Town now is 10.10.103.1. This one we make it 103.2. So this IP address, it's 10.10.103.2, and then it's also a /30 network, 255.255.255.252, and then no shutdown. And then exits, and so let's configure now the we need to configure Johannesburg and Cape Town side of the new WAN. So let's go to Johannesburg. And then configure, first enable, and then configure terminal, so interface serial 0/0/0, and then IP address, so it's 10.10.102. remember we said .1, that's Johannesburg .1, so Pretoria is 102.2. you must just keep that in mind so that you don't make mistakes. And then it's a /30 network as well, so it's 255.255.255.252. Oof, had an error there. Okay, and then we need to put the clock rate of 64,000, and then no shutdown, and then exit, and then end. Okay, now we also need to configure Cape Town for the new serial to Bloemfontein. Let's enable, and then configure terminal, and then the interface is serial 0/3/1, and then IP address 10.10.103.1, and then it's a /30 network 255.255.252, and then the clock rate at 64,000, and then no shutdown, exit, and now the key part is that we need to configure OSPF on all routers to use multiple areas, and our area design is area 0 contains the WAN backbone, links, and then and Durban. So area 1 contains Johannesburg and Pretoria, and then area 2 contains Cape Town and Bloemfontein. And now on Johannesburg router is the ABR, or rather the bridge between area 0 and area 1. And then Cape Town is also ABR between area 0 and area 2. Now on Johannesburg router, is the most important router to configure correctly, because it sits in both area 0 and area 1. So it's when interface is facing Durban, and then Cape Town are in area 0, and then its LAN interfaces and Pretoria when link are in area 1. Alright, so let's go ahead and enable here, and then configure terminal. And then let's router OSPF 1. And then the router ID, it's 1.1.1.1. Alright, now we need area 1, which is Johannesburg LAN subnets, finance, HR, IT, and VLAN, IT VLANs. So let's network 10.10.1.0, and then 0.0.0.255. So that's area 1. And here I'm just going to change, so it's going to be 10.10.2.0. And let's do the same thing with IT. Alright, then we need area 1 when linked to Pretoria. So it's going to be network 10.10.102.0, and then 0.0.0.3 area 1. So that's just a WAN link to Pretoria. Then we need an area 0, which is WAN link to Cape Town. So that's a backbone. So that's network 10.10.100.0 0.0.0.3. So it's area 0. And then area 0 when linked to Durban. So Durban we just change to 101. It's the only thing that we change. Now we need passive interfaces basically, and then I'll just explain the code. So because the LAN VLANs do not need OSPF hellos basically, so we're gonna do passive interface default. Okay, let me just fix the spelling of passive. We say no passive interface on serial and then the last one is 0, 0. Okay. All right. And then we need route summarization. So we need to advertise Johannesburg and Pretoria subnets as a primary into the area 0. So we'll just say area 1 range 10.10.0.0 and then 255.255.248.0 and then end. All right, now let me explain this area design on Johannesburg router. So the Johannesburg LAN subnets and the Pretoria WAN link area are in area 1. Right, so these are the internal networks of Gauteng region. So the WAN links to Cape Town and Durban are in area 0. So that's the backbone. Now on Johannesburg router is the ABR because it has interfaces in both areas. Right, so the area 1 range command is the summarization, which is the 10.10.0.0 with the mask of 255.255.48.0. So that is a /21, okay, which covers all addresses from 10.10.00 to 10.10.7.255. So basically it just summarizes all our Johannesburg and Pretoria subnet into one advertisement that is sent into area 0 instead of the individual /24 routes. So routers in area 0 and area 2 see one summary instead of 4 individual routes. Now let's just go to Pretoria. Now we're gonna enable and then configure terminal and then router OSPF 1, then the router ID. The ID is 4.4.4.4. Now we need to do Pretoria LAN, which is network 10.10.6.0 and then 0.0.0.255, which is area 1. And then the next thing is a WAN link to Johannesburg, so also it's in area 1. There's network 10.10.102.0 0.0.0.3, which is area 1. Then we need to do passive interface. Okay, I don't know what did I do there. So let's re-enter config again, and then we can do passive interface, which is gigabit Ethernet 0/0. Gigabit Ethernet 0/0. All right, and then end. So so the Pretoria router is actually a pure just pure internal router. All its interfaces are in area 1. So it has a simple OSPF configuration and a router ID of 4.4.4.4. So Pretoria is our fourth site, basically. So both its LAN and WAN interfaces are in area 1. It will form an OSPF adjacency with the Johannesburg router over a serial link. Alright, now let's go to Cape Town and then configure. So Cape Town is the ABR for area 0 and area 2. So first we enable and then configure terminal. And then router OSPF 1. And then the router ID is 2.2.2.2. Alright, so we need to do the Cape Town LAN network will be 10.10.4.0 and 0.0.0.255, and then this is area 2. Yeah. So this area 2, and then we need to do a WAN link to Bloemfontein. So it's gonna be network 10.10.103.3 and then 0.0.0.3 area 2. All right. And then we need area 0 backbone, which is a WAN link to Johannesburg. So that's gonna be network 10.10.100.0 and then 0.0.0.3 area 0. Alright, then we can do a passive interface default. Passive interface alright, and then no passive interface on serial. So here we only have 2 serials, serial 0/3/0, and then the other one is 0/3/1/3/1. And then finally we summarize area 2 subnets into area 0. So we say area 2 range 10.10.4.0, and then there's gonna be 255.255.255 sorry, .254 actually, and then .0 and end. All right, so the Cape Town router is now ABR for area 2. So I mean, its Cape Town LAN and Bloemfontein WAN link are in area 2, while its Johannesburg WAN link is in area 0. So the summarization of 10.10.4.0/23 covers both Cape Town, which is 10.10.4.0, and Bloemfontein, which is 10.10.7.0. Actually, let me be precise. 10.10.4.0 255.255.254.0 is a /23 covering 10.10.4.0 to 10.10.2.5.255. So for Bloemfontein, at 10.10.7.0, we need a broader summary or a separate advertisement. So let us use a two area statements. Okay, so let's go back to configure terminal, and then so we're gonna say router OSPF1, right? Then we're gonna have area 2 range 10.4.0, and then 255.255.255.0, and then say area 2 range 10.10.7.0 and 255.255.255.0. So we just separate summaries for Cape Town and Bloemfontein since they are not contiguous. And then end. Okay. So since 10.10.4.0 and 10.10.7.0 are not contiguous, so they cannot be combined into a single summary without including addresses that do not exist in the network. So we use two separate area range statements. So this is a real network design consideration. Always check that your summary actually matches only the networks that you want to advertise. All right, now let's go to Bloemfontein. Where is Bloemfontein? There is BLM. Okay, enable, and then let's configure terminal. And then router OSPF1, and then router ID 5.5.5.5. Now for Bloemfontein LAN network 10.10.7.0 and 0.0.0.255, so it's area 2, and then when linked to Cape Town is network is network 10.10.103.0 and then 0.0.0.3 area 2. Okay, and then we can just do passive interface gigabit Ethernet 0/0. And then end. Now Durban remains in area 0, So Durban stays in area 0. It connects directly to the backbone, so there is no ABR needed. Its configuration from the previous lesson that we did is unchanged. All right, so this is fine. Not every site needs its own area. I mean, small remote sites with a single router are often left in area 0. Now if we go to, let's just check Johannesburg, and then I'm gonna show IP route, or actually show our IP interface brief. Then you'll see that both gigabit G0 and G01, they are down. So what we need to do is we need to bring up G0 and configure sub interfaces on the Johannesburg router. Alright, so let's go ahead and do that. So we're gonna enable and then configure terminal. Alright, so configure terminal, and then we start with interface gigabit Ethernet 0/0. This is G0, and then no shutdown. Okay, now it's up, and then exit. The Johannesburg LAN subnets and the Pretoria WAN link are in area 1. Okay, so let's go ahead and show OSPF on Johannesburg. So we're gonna show IP OSPF neighbor. So it's time for, we can do end-to-end test. So but the whole point, instead of just one giant OSPF area where every router knows everything, we split this into 3 areas. All right, so this just changes, the changes in area 1, which is Gauteng, do not affect area 0, area 2 routers. I mean, smaller routing tables, faster reconvergence, better scalability as well. If we want to add other cities, we can, like we've already added Bloemfontein, right, and Pretoria. So if we want to add Polokwane, we want to add whatever city, Kimberley. Now the question is, why both ends need like Cape Town to and Durban, right, or Cape Town to Johannesburg link, and then Durban to the end of Johannesburg link? Why do both need an IP? Because the thing is, a WAN link has 2 ends. Like a phone call needs 2 people, right? So the router Johannesburg has 1 on its side, and then the Cape Town must have 2 on its side. Same subnets, different host addresses. So if one end has an IP, then the link is like a phone where only one person picked up. So each router has its own serial module installed in different slots as well. So the interface number reflects the physical slot. So you must be careful about that, especially if you you want to install the serial cards or the serial modules. Sometimes you might install it on 00 serial 000. So you must just check where you install it. So the only issue is that when we install it on the 3rd slot and the 4th slot. All right, so you must always check show IP interface brief on each router to confirm the correct interface before you configuring. And then now on Johannesburg router, sort of highlight that So the router ID, every OSPF router needs a unique identity, like an ID number. So we manually set it to 1.1.1.1 for Johannesburg so that it's easy to recognize in the show command. So if you do not set it manually, the router picks one random, from its interface IP. So which makes troubleshooting a little bit confusing. Now, if you check here, then we've got two different areas in Johannesburg, area 0 and area 1. Because the thing is, the Johannesburg router is the ABR, so it's the area border router, right? So it has 1 foot in the area 0, which is the backbone, and 1 foot in the area 1, which is Gauteng. Now, the WAN links to Cape Town and Durban goes in area 0 because they are backbone links connecting the main sites. So the Johannesburg VLAN and the Pretoria WAN goes in area 1 because they are internal to Gauteng, or the internal Gauteng network. So the Johannesburg router just bridges between them. Now, if we check the network 10.10.1.0 and then 0.0.0.255 in area 1, this command has three parts: the network address, which is 10.10.1.0, and then the wildcard mask, which is 0.0.0.255, which just says match any address starting with 10.10.1 something. That's all we are saying there, right? So the area 1, it tells OSPF that find any interface on this router whose IP starts with 10.10.1 something, and then just enable OSPF on that interface and put it on area 1. Now, like I said, the 0.0.0.255 and the 0.0.0.3 wildcards. So the 0.0.0.255 is a /24 subnet. It covers all 254 hosts in the subnet. It's used for LAN interfaces. And then the 0.0.0.3 is a /30 subnet. It covers only for addresses. So it's used for WAN points, when point-to-point links. So the wildcard is just the inverse of the subnet mask. Now, then we did the passive interface default, because the thing is, by default, OSPF sends hello packets out to every interface. So including the Johannesburg VLAN interfaces facing PCs and switches. So PCs do not run OSPF. Now, sending hellos to them wastes bandwidth, and it's actually a security risk as well. So this is just a command that just makes all interfaces passive. That means no hellos. Then we undo it only on the serial interfaces that face other OSPF routers. Now, the default information originate the router Johannesburg or Johannesburg's router has a default route of 0.0.0/0, pointing to the ISP router for internet access. So this command just tells OSPF, share the default route with all of your OSPF neighbors. And then Cape Town and Durban and Pretoria will automatically receive a route to the internet. All right, a route to the internet without us manually configuring the default route on each of them. So if we look into Cape Town, let's actually go to and look what we've done in Cape Town. All right, so we did the same thing, right? I'm just gonna highlight. Cape Town is also ABR. Cape Town connects area 2, which is Cape Town, to area 0 backbone. So its LAN interface and any future Cape Town bridges goes to area 2. And then its WAN link back to Johannesburg is area 1. So it is a gateway between Cape Town and the rest of, the network. And then we gave it router ID again, which is our second site. So 2.2.2.2 is easy to remember, and it identifies Cape Town's instantly in any show command output. Now, on Cape Town, we did passive interface gigabit Ethernet 0/0 So the G0/0 faces the Cape Town LAN switch and PCs. So we only need OSPF hellos on the serial WAN interface facing, facing Johannesburg, not the LAN site. And then we did the same thing in Durban as well. But in Durban it was slightly different because Durban connects directly to the backbone WAN, so it is a small remote site with one router, not worth creating a separate area for. So putting it on area 0 is perfectly valid and simpler. Only sites with multiple routers or significant internal topology benefit from their own area. So Durban is not ABR because both its interfaces, the LAN and WAN, in area 0, so it has no area boundary to manage. So it's just simple. It's just simple internal area 0 router. All right, so let's check Johannesburg before we do end to end. Now you can see here the three neighbors are all in full state. You can see that the state says full. So OSPF multi-area is working. So full means that the routers have fully synchronized, so their link state database are actively sharing routes. So any state other than full means something is still misconfigured.